we were talking about strategy. So strategy, it's about decoupling or removing the dependencies on functions. It's like I want to implement a function in my class, but I know that that function will change in time. So how can I handle this case? Because I don't want to go back and change the class again and again and again each time that function will change. Okay, so in C and C++, as I said, as I was saying, you can do this easily with pointers to methods, to functions. In .NET, you can use delegates. In Java, you don't have any other specific tools other than objects, because in Java, you have only objects. Okay, so in order to do that, if we go and check the definition, so you see the problem here, it's saying that the function will change because others will want to do that, because you depend on external conditions. And it's clear here. This strategy is established by the marketing department, and changes depend on other campaigns. So, which actually means the marketing department will go to you and say, hey, change the add bonus points because now it's Easter, and we want to we have a specific campaign for Easter. And after that, in 1 month, you have the International Child Day, June 1st. So again, we want to provide bonuses. And after that, you have the summer campaign, whatever. So this is changing a lot. And here, the specific of these problems are based on this. Others, external entities, will establish how that function will behave. So you have zero control, you as an object. You have the function, but you have zero control on what the function should do. Okay, so this is the issue, how you can implement different versions or change a function without actually changing it. So if we go back to the diagrams, okay, and check the strategy. Okay, here is the standard way of implementing loose coupling at functions level. So this is how you decouple or remove dependencies on functions. So here, normally, without knowing about this pattern, you will implement this logic here, and now you provide the Easter holiday bonus strategy. So you implement the function here. This is like add bonus points to our players. And in 1 month, you need to go back here in the player class and change the function, like delete it, rewrite it again, because you have a different new strategy. So that's not okay. So strategy is saying this, hey, let's outsource the function. How do you do that? You define an interface which defines the interface of that method, the signature of that method, or methods, because here you can have multiple, a strategy handling multiple functions. Normally try to keep this as a one-to-one relation because it's easier to handle it. So, which is what we will do today. Okay, so we define this interface where we have the signature of that method. And after that, here, each class which will implement this interface will focus on a specific strategy specific to a particular campaign, like Easter, June 1st, summer, Black Friday, whatever. So in this way, here, when we will implement these classes, we will actually implement different versions of this method. So here you will have the source code specific to Easter campaign, June 1st campaign, and so on. So if you want to add new versions of the function, you just add the new class here in this framework. And by doing that, you don't change anything here in the player class. This is the idea, and this is how you outsource functions. And this is strategy. It's the basic way to do this. Now, the player is still the one that is handling getting the bonus points. So the player will still have this function. But when someone will call this function for the players, like get the bonus points, here, again, we will do a callback to this reference, which at that particular moment will pinpoint to the current strategy, Eastern, June 1st, summer, whatever. And you see, by using this reference, is like at each moment in time, we can actually change this function without actually changing the lines here, the source lines here, by actually pinpointing to different objects which will handle that for us. So it's like, hey, now I want to use that version of a function. This reference will pinpoint to an object of this type, of this class type. Later, I want to change the strategy to June 1st. I will reinitialize this reference to an object of this type and so on. So at any moment, someone can say to this player class or this player object, hey, use the Eastern campaign now, use the June 1st strategy, or use the summer campaign. So the marketing department can decide which will be the rules for granting those bonus points right now or tomorrow or next week. And in that way, by using this approach, we are actually calling this set strategy or set campaign mode function. And the role of this method, and if you remember the course on this topic, this is very important for strategy. This method is the key signature method for the strategy pattern, because without this method, without this set method, which actually changes this reference here, you can't actually change the strategy. So this is very important, because without this method, you can't change the strategy. Your object will be stuck with one strategy forever. So you need this method. This is very important. So changing the function version, it's simple. You just call set strategy with different objects from this family. And after that, when you call the do that operation, grant the bonus points, you actually do a callback to this reference, and that object will execute the function specific to the current campaign. Okay, so this is the standard way to outsource functions. So let's do this in our project. So let's add a new package. Let's call this one strategy. And obviously here we will have the player class. So new class, this is the player. So here you have the username of the player. Okay, we can have the hours played, number of hours played, or played hours, or yeah, this is playtime. Yeah, this is more correct. Playtime in hours. Okay, maybe you have I don't know, experience level, experience points, and so on. So let's suppose that if it's Easter holiday, which was several days ago, if you play this game, because we know it's holiday, so we want to get all your available time to play our game. If you play during those dates, maybe you get double points because it's Easter, so the Easter Bunny will give you extra points for that. So here you will have a constructor just to initialize the player. Okay, and normally here you will have this a function called public. It's a public function. Void get bonus points or get experience points. Yeah, let's see, get experience points. And let's suppose that normally you get this experience points based on some points that you got during the game. So int points received. Okay, so normally here you will do an if, or maybe here you will have an extra argument saying which is the current campaign. It's the Easter campaign, it's the June 1st campaign, it's the summer campaign, whatever. And here you will do a lot of ifs, or each time the marketing department say, no, Easter holiday is over, let's prepare for June 1st. So here they will say to you, okay, go here and remove the Easter holiday and just grant the points as in a normal way. So here you will have this experience points plus equals points received. And yeah, this is the normal game experience when you don't have a bonus campaign, okay? And in 3 weeks, they will call you and say, okay, we prepared for June 1st, delete this or comment this, whatever, delete this, and now grant, I don't know, double points because it's June 1st or whatever. So without the strategy partner, you will go back and change this method a lot of times. And we don't want to do this. That's why we are talking about strategy. So based on the diagram, we need to define an interface for classes that will handle different versions of that function. And for us, that function is this one, the get experience points. So let's define an interface, and this will be the bonus strategy interface. Okay, and here we define that method, public void get bonus points. And here you get the normal points that you will normally receive. And now we use a multiplier like 2x, 3x. So we multiply the points that you normally get. Okay, so this is the interface of the bonus strategy. And having this interface now, we can create this relation to the objects that will provide this strategy to us. So if I go back into the player class, now I will define this bonus strategy interface. So this will be the bonus campaign. Okay, null. And as a reminder, it's very important for strategy to allow me to change the strategy whenever I want to do that. So it's very important to provide a method similar to the set method. So source generate getter and setters, and I want for my experience points, for my bonus campaign, I want the setter. Okay, so I want the set method that will allow me to change this reference. Okay, so now I can change the current campaign, and based on that, hopefully I get different behaviors for these get experience points. So instead of implementing and changing this function now and doing this story for the rest of the months, now I will do this. If this bonus campaign is different than null, then I will do a callback to that object method saying this bonus campaign get bonus points, and now you pass the points received. Now here we have an issue. If those strategies need to change something here in the player, at this point, they don't have access to the player. You see, we didn't have this issue earlier because get experience points was a function from this class. So you had access to all the attributes. So if you want to allow the strategy to access data from the object itself, or to allow the strategy to change something in the object, then you need to pass the reference to the object. So here, when you define the strategy interface, here we should say, okay, I need the points, because based on that, I will compute the bonus points, and also I will need the reference to the player. Okay, because in that way, the strategy can add these points with the multiplier to the player experience. Okay, so keep this in mind. If the strategy object needs a way to access your object, then you need to pass the reference. And in this way, you have the two-way binding. Okay, you can read and write inside the player. Now, if you don't need to write or change anything in the player, you can pass the values here as variables. You can pass the experience points here as a parameter. So now get bonus points also means to pass the reference to the player itself, because we want to change the experience points based on the strategy. Okay, so let's define two different campaigns. So for example, let's say we have the Easter campaign. Okay, so let's define this class. So in the Easter campaign, what we want to do is to, let's say, if you played already more than 5 hours, maybe you are a new player, we will double the points that you get. So here we will say implements bonus strategy interface. And now we need to implement that method, the get bonus points. So here I will do this. If player playtime greater than, let's say, 5 hours, okay, then you get double of points. So this, player experience points plus equals 2 multiply with points. Okay, so if you are a new player and you just started the game, if you played more than 5 hours, you get double points. So we want to make them play at least for 5 hours, especially the new players. So this is the Easter campaign. Now we can define a different campaign. Let's say this is the summer campaign. So new class, summer campaign. Okay, implements bonus strategy interface. Again, here, add implemented methods. And now you can do this differently. For example, during the summer, all the players get all the time. So it doesn't matter how many hours they played already. They already get this player experience points plus equals, let's say, 1.5. So you increase that by 50%, multiply with points. Okay, and obviously you can have the normal strategy. So new class, here you will have normal strategy, let's say, or normal campaign, or no campaign at all. Campaign. Okay, where you just don't apply any bonuses. Implements bonus strategy interface, and here you just do this player experience points plus equals points. Okay, so at this point, if you want to change the way you give bonus points, you just define a new class and that's it. Nothing will be changed here in the existing classes, and nothing will going to change here in the player class, because you see, you add new versions of that for that function by adding new classes, and you keep everything as it was. So how do we test the strategy? How can we see that this will work? So test strategy, public static void main. And here we will create a player. Okay, and here I need a username, let's say is John. Playtime, let's say it has already 10 hours of playtime, and experience points, let's say 100. So for strategy, it's important to understand that you need to set a strategy, okay? And this is important. So player, now some of you may say, okay, can we set a default strategy? Yes, you can do that. So you can go here in the player and say, instead of equals null, you can say equals new no campaign, okay, which is the default strategy or whatever. Okay, so you can do that. It's optional. So let's say here we say set bonus campaign, new no campaign at all. So now if the player plays the game and get the points, it will get them as normal as that could be. get experience points. Let's say it got 150 points. So now it just get the experience points. After that, let's say it was Easter. So set bonus campaign, new Easter campaign. Okay, and now if we'll play, it will get double of that. We can print those points. Okay, and here you will have player experience points. Okay, here and here. Okay, and if you change the strategy, let's say it's over, and now you want to go to a new summer campaign or summer strategy, and you play this, now you will get other points. And you see here, the client is deciding which is the strategy that the object should use. So the object has zero control over that. And that's why this method set is very important. And you will see this pattern for strategies. So if you see a source code and you see that they are changing, doing something similar, and after that they call this method or a method, this is a signature of this pattern, of the strategy, because it's obvious that someone is changing the strategy, and after that it's using it here by calling the object method. And here transparently, the object is doing a callback to the method implemented by this class here. Also, some of you may say, so here some of you will say, maybe this is not efficient to just create these objects again and again, because at some point you want to reuse them. So in that case, you can manage the strategy objects by implementing a factory. Okay, so you can combine multiple patterns into the same solution. Because, yeah, if you reuse these objects again and again, this is not efficient to just recreate them. So that will be another approach how to handle them. So if I run this code, this source code, you see the points are changing differently, because initially I got 100 points. After that, I have 250 points because there is no bonus campaign in place. So you get 250. After that, you have the Eastern campaign, which is 2x multiplier. So you got 250, and now you get 150 multiplied by 2. So you got in the end, you have 550 points. And this one is the other one with the 1.5 multiplier. So here you get more points based on the summer campaign. Okay, and what's important here, also based on the state machine which follows, is this: someone is deciding what the object should do by calling this set bonus campaign, set bonus campaign, set bonus campaign. Okay, and this is very important for strategy. So strategy helps you outsource functions, is like removing the function implementation from your class. And strategy means that someone else is deciding at any moment what the object will do by setting the current strategy. Okay, so this is what strategy helps us achieve. Okay, outsource the function implementation, give you control over what the object will do. On the other hand, because they have the same diagram, so it's the same approach. State is also helping you outsource functions. It's helping you implement functions outside of your class. But the difference is in the way you decide which is the current strategy. So for strategy, someone will decide that for the object. You will see this, okay? But for state, for the state machine, the object is deciding that for itself. And this is very important. This is a state machine. The object is able to change its strategy / state, and we will use state, based on its own values. And that's why it's called a state machine. Remember, the state of an object is the collection of values for its attributes. If you change one of the attributes, if you change the value of one of its attributes, you change the state of the object, right? Because it will have a different state, a different combination of values. So this is the difference. They both help you outsource functions, but strategy is decided by others. State is generally decided by the object. So this is the last problem. And the implementation and the diagram are identical. I highlighted that during the course. So we should see the differences in the source code, not in the general architecture of the solution. So here he's saying that the game characters' actions are affected by their state. The gameplay is different, the action effects are different, the way the superhero moves is affected by its state, life points. So let's do this. How can we change the way the superhero moves based on how many life points it has? So let's define the package for state. State. Okay, let's close all the other files. So we have this superhero class, which we already implemented many times, superhero. Okay, and here you have this classic string name. And here you have the life points. We already covered that, life points. And maybe you have other attributes like, I don't know, attack, strength, whatever. So you have a lot of values, a lot of attributes. Now, all these attributes and their values are defining the superhero state. For example, name is Superman, life points is 100. That's the state of your superhero at that moment. If you lose some life points, it means the object state will be changed because you have less life points as before. This variable, this attribute will have a different value. And here we had this action, which was called move, public void move. So here, generally, we want to show that the superhero is wounded. So if he's not wounded, let's say we have this threshold value, which is called public static final int critical value, which means if you have less than 50 life points, it means you are critically wounded. And maybe we have another one, static final int wounded value or threshold. Let's say it's 200. Okay. And everything which is above wounded value means you are normal. Okay, so what do you do here? You will again write a lot of ifs. If life points less than 50, you say, hey, it can't move because it's critically wounded. Or if it's between 50 and 200, it means it will just move slowly because it's wounded, and so on and so on. And this may also, in time, increase in complexity because you want to add new rules. You want to add new visual effects, and so on and so on. And this is just for move. You can do that for other different actions. So at this point, you will implement those complex logic here, verifying these values against the life points value against these standard values. And obviously in time, if you want to change move, you need to go back, change the superhero class. So how can we implement a function and change the function in the future without actually changing the class itself? Again, we need to outsource move. We need to outsource how move will behave depending on different conditions. And this is something we already done using the strategy pattern. So if you check the state pattern, you will see it has the same diagram. This is your class. This is where you handle different versions of that function. You have an interface, and here you have different implementations. Again, you have a reference to this, to the objects here, and you do a callback here in that request. So it's the same story. So let's implement that one, and I will show you where is the difference. So obviously here we have an interface, and let's say this is called the move state interface. Okay, and here we can say public void. I will use a different function name just to show you, yeah, it's not the same function. Move on of a different location, let's say. And this is the function that we want to outsource to move the superhero on the screen. So let's suppose you have the normal state. So let's define the normal state. So new class, you see it's the same as with strategy. Normal state, where you are not wounded. Okay, normal state. So here you implements move state interface, normal state. Okay, and add an implemented method. So here we will say print a message. System out print line. Again, if you need access to the object itself, so if you here in this function, you need to change something in your superhero or you need something from your superhero, again, like we did with strategy, here you can pass a reference to your hero. Okay, so again, it's an option. If you need that, you can do it. So here I will just say a generic message. The hero is running because, yeah, it has no issues. Now let's define the wounded state. Wounded state. Okay, and here you say implements move state interface. And here I will write a message like the hero is moving slowly. Okay, because it's wounded. And the last state, the last strategy, but it's state here, we will use the proper name, let's say, is critical wounded state. And here we implement the same interface. Implements move state interface. Okay, add unimplemented methods. And here we say the hero can't move. Okay, so you have three different states. Critical wounded, it can't move. Wounded state, it can move but slowly. Normal state is running. So now having this family of states, now we can go back to superhero and say, I will not implement all the logic here in move because I have other objects which are implementing the move state interface. Okay. And those objects will help me deal with that. So here I will say, if this move state different than null, do this. This move state, move at a different location. Otherwise, that's not a good thing. Throw new unsupported operation exception. Okay, so you see now I delegate what I should implement here to other objects which we are focused on simpler use cases, normal, wounded, critical wounded state. Okay, so where is the difference? Because at this point, if we stop here, this is like strategy. So now if we test the superhero, then we need to change the state as we did as before. Remember, the difference between state and strategy is that the object in the state pattern has the power to change its own state. So because of that, here it's normal, and if you cross-check this with the discussion you had at the design system information design course, the one with UML, if you cover the state diagram of an object, of an entity, then you know that you start with an initial state. So a subtle difference between strategy and state is that normally when you initialize your object, and if that object is a state machine, so generate constructor using fields, So you initialize the object. You generally set the object in an initial state, and you can do that here. So for state machines, this is something you should do. For strategy, maybe it's optional, but for state machines, it's more important than in the strategy case. So here we should set this move state equals new normal state. Okay, so generally in a state machine, you should not have this reference null. So the probability to have the reference null should be almost 0. Now for strategy, it depends. Okay, so, or you can do it here, okay, if you don't want to bother it here in the constructor. So how do we change the state? Now, if you check the diagram, you will see that in Go, they also suggest you to have the set state method here. But this is not so important as for strategy, because for strategy, this is the way that external entities are changing the strategy. But for state, remember the power that the object has over the ability to change its own state. So in this example, I will not implement the set method because I want to highlight the difference, the logic difference between state and strategy. So I will not implement the set state. And generally, if you have a state machine which is not affected by the environment, this is the way you should implement that class. And it's a normal way for state machines not to be directly affected by external entities, as we have seen for the strategy test. So I will not implement the set state because in this way, it's obviously it's mandatory to change the state somewhere here. So how do we do that? Now, remember we had, when we talked about superheroes, we had this method called take a hit. And here, the hero will lose some points. And normally here you will say the superhero got a hit and we did this. This life points minus equals points. Yeah, but wait a minute, what's happening now? If you change life points, it means you change the state of the superhero. It doesn't have the initial number of life points, it has less. So changing the state of the object, remember what was the issue? The way the superhero moves is affected by its state, life points. So in this case, it means that if the life points has been decreased, we need to check if maybe now the superhero is in a wounded state or a critical wounded state. So we do this. If these life points less than critical, less or let's say equal than critical, okay, then it means it's critically wounded. So I will say this move state equals new critical wounded state. And you see, the object is changing its own strategy because it's handling the change of its state, the life points value. And now it's saying, okay, we need to update how we move because now we may be critically wounded. Else, if this life points less or equal than wounded value, then this move state equals new wounded state. Okay, so in this case, when you take a hit, when the superhero takes a hit, it will update its own state and it will also change its own strategy regarding move. So this is done transparently. We don't need to intervene. The object takes care of that. And also we have the opposite function, which was called heal. And here we can do the reverse. So normally here you say this life points plus equals points. And now you can change the way the superhero moves because you have more and more life points. So if this life points greater or equal than wounded value, then again I will say this move state equals new normal state. Okay, and else if this life points greater than, because it was less and equal, so greater than critical value, it means this move state equals new wounded state. Okay, now else it means you are already in critical state, so you don't need to change anything. You didn't pass the critical value point. Okay, so how do we test this? And this is the last part, so we finish here. So test state. And this is where you will see again the difference between state and strategy. We create a superhero, Superman. New superhero. Okay, so this is Superman. And initial life points, let's say 500, whatever. And now if you ask Superman to move, it will move normally, move. Okay, now if Superman takes a hit, okay, let's say 200 points. Let's see, the levels were here, 250. So let's hit this one with 350 points. Okay, and after that, Superman move. Okay, and if we hit it more, so it's under 200, it's 150. Let's hit it for 160 points. Okay, so if we run this now, you see the hero is running, so initially was running, took a hit of 350 points. The hero is moving slowly because now he has only 150 points left. And after that, yeah, I think here it's not 160, it's game over already. So it's 150 minus 90, okay? 90, 60 points, no, 110. We can do a game over state. Okay, the hero can't move, it's okay because it has only 40 or something points. And if the Superman is healing, let's say 500 points, and you make it move again, it will run again because it's already past the wounded point. So what's the difference here? Where is the strategy change? Where do we change the superhero moves? We don't do that. You see, we interact with the superhero. The superhero is doing its own actions, and when it's changing its state in terms of life points, the object is alone updating the current strategy for move. And this is the difference between strategy and state. Remember, you have a remote controlled robot, which you instruct what to do here. So you have a joystick-like remote control, and you say, move there, do that. And for a state machine, you have a smart robot. You just press start, and the robot is moving around, I don't know, the place. You don't need to guide it, okay? It's a smart robot. So that's the difference between the state pattern and the strategy pattern, because the implementation is the same. The difference is here. You need to show that the object is able to change its own state by different means. And we did that here in the superhero class, okay, on take a hit and heal. Now, for the strategy, the object has no idea which will be the strategy, and that's why it's very important for that object to receive the strategy by an external input using the set bonus campaign function. And these are the two patterns. So they both help you outsource functions. You implement functions in other classes and you do loose coupling, which is dependency inversion at function level. And the difference is that for strategy, the client decides the strategy for the object, and for state, the object has the power to decide its own strategy. It can accept external inputs, but generally in a state machine, the object changes the version of the function based on its state.